Continuing with 7.3, we are now on integrals, and the formula for the integral, b to the x dx. Now this works only if you're talking about an x. When you start talking about something besides x, then it's going to be a u kind of problem. So this turns out to be 1 over the natural log of b, because we have to take care of the natural log of b that you put in a problem when you take its derivative, b to the x plus some constant c. Now it works fine until we do a u problem, which is exactly what happens in example 4a. We are integrating x times 3 to the x squared dx. So in this case, we're going to let our u be x squared, which means du is 2x dx. Now if I look over at my original problem, I have the u, it's right there. I have an x right down here, but I need a 2. So I'm going to insert a 2 and put a 1/2 in front. So this turns out to be 3 to the u du. Now, according to my rule, I've got this little 1/2 hanging out here. The rule is it's 1 over the natural log of the base, which is 3, and then 3 to the u plus c. But I've got to change my u back, so it becomes 1 over 2 the natural log of 3, 3 to the x squared plus c. Let's look at part B. Now this one's a definite integral from 1 to 4, 6 to the negative square root of x over the square root of x dx. Again, we're going to pick our u to be the exponent. And remember, that's x to the 1/2. So du is going to be 1/2 x to the negative 1/2 dx, which if I clean that up, it's negative 1 over 2 the square root of x dx. So again, looking at my original problem, I have the u right there. I have almost all of my du. I have the square root of x in the bottom, but I need a negative 1/2 in there. So I'm going to insert a negative 1/2, which means I have to put a negative 2 on the outside to counteract it. And so this turns into the 6e to the negative square root of x is 6 to the u, and all the other stuff there is your du, but we have to change our values. So we started out with x being 4, which makes u negative the square root of 4, or negative 2. So negative 2 goes on top. And then when x is 1, we get u is equal to negative the square root of 1, or negative 1 for the bottom. Now we're going to integrate, and the integral is 1 over the natural log of 6, 6 to the u, no plus c because we have numbers, and since we changed the x's to u's, we don't have to go back. So this becomes negative 2 over the natural log of 6 times 6 to the negative 2 minus 6 to the negative 1, which would be negative 2 over ln of 6. This right here is 1 over 36. And this is 1 over 6. If I put those fractions together, that would be 1 over 36 minus 6 over 36. So that would be a negative 5 over 36. So I end up getting 10 over 36, the natural log of 6, but I can reduce the 10 and the 36 and make it 5 over 18, the natural log of 6. And we have the general power rule, which we have been using right along. It's just that now we're going to use it on weird things, weird numbers. And so 5, part A, y is equal to x to the pi, and they want us to take the derivative. Okay, y prime is going to be, pi is a number, it comes in front, x to the 1 less power, and that's the best you can do with that. Part B wants us to take the derivative of y equals pi to the x. Okay, but now the exponent is a variable. So now we have to use like the e or the b to the u, b to the x problem. So its derivative is b to the x times the natural log of the base times the derivative of the exponent, which is 1. So that's just going to be pi x times the natural log of pi. Part C. The difference between A and B. The exponent on A was a number, so it's a regular old power rule. But the exponent on B was a variable, and that's when you have to use our new rules for b to the x. So now I'm doing y equals x squared plus 4 to the e. Again, e is a number, so I pull the e in front, this junk, to the 1 less power, but then times the derivative of the junk. So if I clean that up, it would be 2ex x squared plus 4e to the e minus 1.